Hello, everyone. Welcome. This webinar is titled What's New in Globus? Just wanted to make everyone aware that the event is being recorded, and we'll post the recording along with slides to the Internet to Tech Extra website. I'm going to get started in just a little bit here. You're more than welcome to ask questions while I'm presenting. Please feel free to put them in the Q&A, or you can put them in the chat. We have Kelly and Susan standing by to help us moderate that. They'll get my attention and I can answer them as we go along. So thank you for joining. I'll begin in just a few seconds here. Okay, welcome to What's New in Globus. So as I was preparing this talk, I went back to see when was the last time that I had actually spoken with the Internet 2 community or engaged with this group. And it turns out it was almost 3 years ago in DC at the Global Summit. So that was quite an eye-opener, actually, quite scary. But then I sort of reflected on the 3 years and how much progress we've made. And I'm sure everybody else has, despite the challenges, done some wonderful things too in the interim. But we've been building a few things on the Globus end, and that's what I want to talk about today. On the one hand, we've spent a lot of time rebuilding what we call the technical foundation, Globus Connect Server. I'll talk about that. We've greatly expanded the number of systems that are connected or accessible via Globus through connectors. We've added a lot of services to the Globus platform. And in particular, we focused a lot on creating ways for people to automate their data management at scale. So I'll go through each of those in turn, starting with the foundational piece, which is Globus Connect Server. So for those of you that are current Globus users, there's a good chance you're using Globus Connect Server version 4. The current version is version 5. It's been out now for about 18 months, I think, since we had sort of the first general release of version 5.4. And the bullets on this slide capture sort of the high level motivation and some of the major changes that we've made in revamping the entire Globus Connect architecture. One of the biggest things was that we moved from good old-fashioned X509 user certificates and all that to a modern security model based on OAuth 2 and OpenID Connect, which are the sort of the de facto and emerging web standards for authorization, authentication. We also were driven to change the architecture to support the many compliance requirements that have come down the pike over the last few years, both dealing with HIPAA aligned data as well as addressing CUI type environments. The other big thing that was changed was adding or restructuring the Globus Connect software in such a way that it gives you a lot more options with respect to deployment and a lot more options with respect to sharing data, which is one of the big motivations for people using Globus beyond just basic file transfer. And then we also made it substantially easier to scale out Globus endpoints, adding additional nodes and so on. That used to be a very cumbersome process in the past. So let's take a quick look at what the new architecture looks like. So in prior versions, version 4 in particular, and prior versions prior to that, this notion of a Globus endpoint was a single logical thing. So you install the software and on your storage system, and users access the endpoint. That was basically it. In version 5, we've sort of broken up that monolithic stack into a couple different layers here. So what you'll see is on a data transfer node here on the bottom left, a number of components are installed. So we still have the Grid FTP server at the core. That's the data movement software. And then there's an OpenID Connect server, and then a web server, which actually acts, which actually supports the control channel and communication with the Globus Connect server management service that we host. So you can see here a new piece there, the GCS manager. So that's a web service that runs on the node and communicates with the Globus hosted service for, among other things, syncing configurations and so on. And that's, if you look at the bottom of the slide, you can see that being able to sync with the Globus service allows you to easily take configurations that you have deployed on one endpoint and scale them out across multiple data transfer nodes. But arguably the even bigger thing is this next layer up, which is called the storage gateway layer. So here is where you're now able to set access policies depending on the type of storage system that is being accessed, and also depending on what policies you wish to enforce for that storage system. So, for example, you could have a storage gateway, as I'm showing here in the middle, that is subject to high assurance constraints. So that's some of the additional compliance-related security aspects that we added to the service a few years ago. So you could have some part of the file system or the storage system that's subject to that level of access, which has a higher sort of security bar and additional audit logs and so on. In parallel, you could have a storage gateway that talks to some other part of the file system that's not subject to that. And then I'm showing also here a third storage gateway that's talking to a cloud object store. So this can be S3 or whatever, and I'll talk about connectors next year. And so the ability to have these multiple different storage gateways on the same endpoint is really a big deal, because previously, if you wanted to have this kind of setup, you would literally need 3 different data transfer nodes with 3 different service setups. So this has created a lot more flexibility, and it's much more manageable from an administrator's standpoint. And at the top there, those circles are what we now call collections. So this is really the user-facing view of the endpoint in version 5. So when users go to the Globus web app, or whether they access Globus via the command line or what have you, their sort of point of view is this idea of a collection. And there are 2 types. The mapped collection is one that, as the name suggests, maps a Globus login, a Globus identity to a local account on that storage system. So that's sort of the default if you had some high performance file system attached to a compute facility, and users have local accounts for accessing that compute facility and that storage. They could just be mapped coming in through Globus. They just get mapped to their local account and they have access as they normally would. The other type that's up there is the guest collection, and that is again, as the name suggests, for people that don't have mapped accounts, that are guests that are granted access to some data on that storage system by virtue of someone that has a mapped collection. So someone that has access can grant them access through these guest collections. And in version 5, there are much more sort of fine-grained ways of restricting and controlling who can share what, and tracking of all of that. So substantial changes. The current state of this is that we've had sort of parity with the prior version, and as well as all these new additional features. We've had all that out for a while. What we're working on right now is some migration capabilities, so that we can automate migration of the many tens of thousands of endpoints that are out there today. And we've started with that. We're doing it in a phased manner, depending on the type of endpoint that you have set up. So we're reaching out to various cohorts, and over the next probably 6 months at least, we'll be in this mode of helping people migrate over. But we will continue to support version 4 endpoints for quite a long time, until we have the entire community moved over to this new architecture. Okay, so that's one of the sets of big news, and tied to that is the expansion of our connector ecosystem. So we've had connectors to a number of non-Posix storage systems out there for a while now. So we started with S3 many years ago, but in the last couple of years, we've really focused on expanding that to all the major cloud providers. So this is the current list of supported connectors. The few that I'll highlight, which have been released since I last engaged with the Internet 2 folks here. One is Google Cloud Storage. So we had support for Google Drive way back when. We've long since added Google Cloud Storage. So this allows people that have large Google installations to decide what type of storage is appropriate. I know that a lot of folks in this community have Google Drive, have had unlimited Google Drive storage for some time and have been using that as unlimited storage. And I know there are efforts underway to move from that to more data appropriate storage. So putting big research data elsewhere, since especially since some of Google's policies are changing on that front. And one of the many parts of the sort of the value proposition for this is that using Globus to facilitate this type of migration is actually really helpful, because it helps manage or work through the API constraints that almost all of the cloud vendors have in place. So there are things like API rate limits and daily data volume movement limits and things like that. So when you're doing a large scale migration, it really helps to be able to sort of just hand that off to a service like Globus that can work through those things, back off, come back, continue working on the transfer, especially when you have tens of terabytes or more of data, which many researchers certainly do nowadays. So that was the one. Then Microsoft is our latest addition. So we added support for OneDrive and for Microsoft Azure within the last year or so. And so that now brings us to the point where we do support all the major cloud storage systems. And this has been great because we've had our eye on Microsoft, if you will, but we hadn't seen much sort of demand from the research community, and that's sort of changed more recently as more campuses are adopting OneDrive and also looking to use Azure for research data. So I just want to quickly pop over and show what I think is really compelling for folks as they do this kind of migration. So I'm in the Globus web app here, and the one really nice thing I believe is the fact that you can have this unified view of storage irrespective of what the underlying system is. So I'm showing here, I'm looking at my Azure blob storage. So I have this mapped collection. So this is mapping me to an account in the Microsoft world. I could, if I chose to move something to S3 from Azure. Here I am looking at my Globus, my S3 buckets, and I could very easily just go in here and select something and move it into the Globus Vault, and off we go. So it's you still have this point and click approach. There's also the command line and other ways that you can automate this transfer, especially if it's much larger scale. But to first order, for a lot of campuses where they're asking users to move their data between systems, this is a nice way to do it. You provide access to these connectors and to the storage system through connectors, and users can manage their own data movement. And this is true again for Google Drive. I have all the various systems supported, but let's move on. I'm happy to answer more specific questions on that if people are interested. The other thing related to connectors is this community connector program. So this is something that we announced probably about a year ago at Globus World in last April, I think it was, which is allowing or providing a means for others in the community to develop their own connectors and putting in place a shared support model whereby we sort of jointly undertake to support those people that are developing connectors and making sure that they stay current with any changes or updates to the Globus service. And I see there's a question whether the connectors are included in the subscription. So there's a standard subscription, and you can add connectors to that. Each one is an incremental charge. For those that are sort of adding connectors temporarily, if I use that term, if they're in the process of migrating between different systems, certainly that's something you can do. You can sort of come and go. I see another question about moving data. AWS to Azure, does the data hairpin back to the system running Globus? No, so there's no, the data going between the systems, the data flows directly between the systems. So if you're moving from Azure to AWS, vice versa, the data path is between those two systems via whatever routed connection exists between those two. The only thing that's going to Globus is what we call control channel traffic. So Globus is controlling the two endpoints to make sure that that transfer is proceeding and it's working through any transient network errors or file system errors or what have you. But we never see the data. It never goes to Globus. It's not relayed through us in any way. Okay, so one of the early partnerships here with was with Irods, where the team at Renzi took some existing code that was out there from a long time ago and actually did a nice job of packaging it and releasing it in a way that's supported just like any of the other connectors. So now you have nice way to put data into and out of Irods managed storage. And then one other change to the connector landscape, or an enhancement, if you will, is we've added this Posix staging connector, which is basically a means for talking to storage systems where there's an archival tier where moving the data requires that the data be staged from tape to some intermediate storage and then moved somewhere else. So we've designed this as a pluggable architecture, so you can depending on what the archival system is, if we don't have native support for it, you can actually write your own plugin. And I'm showing an example here, one of the first ones, which was written by Brock Palin at UMich, and it's available for people to look at and sort of adopt their own. And we're also happy to work with you on creating these plugins for your whatever storage system you have on the back end. And last but not least, we also changed the way the Globus Connect Personal is installed. So now there's actually sort of a more direct way to do the installation without requiring getting a setup key. So you can just log in to Globus in the course of installing the Globus Connect Personal software on your laptop, and it'll set everything up. However, if you did want to automate that setup, you can, from an admin standpoint, you can actually still use the old key-based approach where you get a key and use that during installation to register the Globus Connect Personal with the Globus service. So so that's it on connectors. I'm going to talk briefly about the new services we've added to the platform, and I'm going to focus on these three: groups, search, and flows. So groups is something that's been around a long time. We've had Globus Groups available, and it's sort of the primary means for doing things like sharing data, so you don't have to share your own, share individually with potentially many hundreds of users. You can put them in groups, and then by virtue of users joining or leaving groups, they get access or they have access revoked on various collections. We've since created or opened up a new API, the version 2 API, we call it, so Groups version 2. So now for those that are using Groups as part of their, in their applications, in their science gateways, in their data portals, data commons, what have you, they can automatically add users to groups and remove users from groups, for instance, when doing data distribution. So if it's a science gateway and you want to create some shared space for users to access their results files from that gateway's code, you can do that all in an automated fashion just using groups. The other big service, and this one I'm particularly excited by this because the sort of the fair data principle is starting to become really entrenched in the community, which I think is wonderful. And we have this this search service that's actually been around for quite some time, but we've really sort of pushed to make this more generally and more easily accessible by folks. And what this is on the back end, it's really just Elasticsearch, but I say just sort of in quotes because really getting data into that search service can actually be quite tricky. So we've tried to really simplify that and provide flexible ways to put data into the search index. And the one big thing is that we're not requiring that that there be a specific schema that the data subscribes to. So you can generally create your own schema for a given index. You can push data into Globus Search using your own schema, and then there are ways to query those indexes either by simple queries through a URL with parameters, or there's a very full-featured query document that you can create and actually post to a search endpoint and get results. And that allows you to do filtering. It allows you to present different facets. So ultimately, where this is most useful is if you're building some kind of data portal or some means for distributing data, perhaps to your collaborators or the broader community, and you want to make the data searchable and findable. And so that's where it comes in handy. And I'm actually going to just pop over briefly to a portal that we set up. This was actually just as a way to demonstrate access through the Open Storage Network. So the OSN, I'm sure most folks are familiar with the OSN that's deploying these high-speed accessible systems, storage systems around the country. So this is just one example of talking to an OSN, to the OSN, and accessing, in this case, the TerraFusion data set, which is a standard observational data set. And so this is, we've put a very simple portal in front of this. So I could log in here. It logs in using, again, it uses Globus Auth to do the login. So I can log in and drop into this portal, and then I can search for data. Actually, in this case, I didn't really need to log in because this is public data, but I'm just sort of showing you some of the things that are capable of. And here you can see this is all driven by Globus Search. So we have a number of facets that are available through the index. So this is metadata that's been put in as part of the ingest process. Again, this is all decided upon by the data owners that are creating the index. So I could choose to limit, to filter the results and just see data from 2000 for that specific orbit group. So I'll see these data sets. I can click on transfer data sets and it will drop me into Globus to transfer them, or I can look at a specific data set and choose to transfer that. So you can see it'll just drop me into that endpoint, and then I can select the destination and move the data. So all very nice and convenient. But the key point is that you now have these massive data sets that you can easily put a customized index on it for whatever purpose you like. And then the third service we added, which I'll talk about that in the context of the next big thing that we've been working on, which is looking for ways to automate and streamline large data flows, or very, very large scale research, particularly as it relates to things like instrument data, which is now, as many people know, order sort of tens of terabytes a day in some cases. And I like to talk about this as in this mode of sort of the 3 degrees of automation. So this is sort of progressively adding greater levels of automation and greater levels of control and customizability to the way you move and share and analyze and search for data. So on the left is the timer service. And then there's this intermediate sort of approach to using the command line and then the Globus flow. So I'll talk about each of these in turn. So the flows, the timer service is really very specific to data transfer. So you can automate, you can think of this, I talk about as Globus cron. A lot of people think of it that way conceptually. It's the same idea. You can create a schedule on which data transfers will be initiated between 2 endpoints or multiple endpoints, and so you can have start dates and you can have it repeat. It can be a one-off thing. So you could envisage a case where you're taking data off an instrument, and every hour or every 12 hours, whatever, you need to push that data out to some archive. Perhaps it's raw sequence data, what have you, or you're just syncing to storage systems. All those kinds of use cases are fair game here. So this is one way to automate things. It's not terribly exciting, but it's actually wonderful from an efficiency standpoint, because you no longer have to worry about triggering these things manually or writing scripts that are more error prone. So this is just a much more reliable, robust way of doing that. The second way, which is going back to scripts, where you really need additional control, or you want to introduce other aspects into that automated flow, where you can have more control. So you can use the command line interface to do that. Again, the command line, the CLI, has been around for a long time, but in the last few months we've released version 3, so that's the latest major version. I think we're at 3.3 right now, or thereabouts, and it's great because it now has support for many of the new things that I just talked about earlier. So it now supports this idea of collections. So you can manage collections on Globus Connect Server version 5 endpoints. It's aware of groups, so you have various group actions that you can take through the CLI. You can also initiate search queries through the CLI. So it's not only available through the portal, through a custom portal that I showed earlier, but you can run it through the CLI. You also have the ability to access the command line as different users by means of profiles. So many of the folks that we work with have affiliations with multiple institutions, and some of those sort of Globus environments are separate, so they need to log in differently. So you can do that now in a much more coherent way. And as part of this, what's also come out is a number of enhancements to the Python SDK that we have that many folks are using to build data portals. So because the CLI is actually built in many respects on top of the SDK, or leverages the SDK. So you could use the command line to do additional sort of more complex automation, but really where we're trying to get to, where we are actually, we've gotten to, and we're in the process of rolling this out at larger scale, is this ability to manage potentially a long-running process of data moving between different stages, even potentially with human intervention along the way, and being able to do that robustly at scale. So if you have an instrument that's generating a lot of data that needs to be moved somewhere, you might do some pre-analysis, then you might do some additional downstream analysis. You might share byproducts or products of those analyses with your collaborators, and then ultimately you might publish some data somewhere, including attaching persistent identifiers to it or what have you. So all those kinds of things, and I've shown a sort of a stylized flow down the bottom here. All those types of activities are very commonplace, and we now have a way to sort of chain these together, and very importantly ensure that they run reliably in sequence, and that they where there's human intervention required, it'll pause and wait for humans to do something and move on. So this is all made possible by the flows service. So that's the platform service that allows you to create and register and run these flows. Within the flows themselves, you have a series of actions to perform different tasks, and each action is performed by an action provider. So we've got action providers written and available for obviously many of the Globus services, but this is another case where we've got an extensible model where you can there's a toolkit for writing your own action provider. So if you wanted to have something happen in the flow that against the resource that we don't currently support, you can always write that action provider yourself. The thing that we're working on, one of the many things we're working on right now, is a service that would allow you to also trigger these flows automatically based on different types of events. So right now, to trigger these flows, you have someone sort of initiating the flow, and then it can run. But that will be automated. So you can envisage an environment where an instrument is generating data as it comes off the device, or some periodic interval, one of these flows is generated that does some analyses, and then and things go from there. And this is an example of such a flow. So this was something that we worked on probably, well, it might be almost 2 years ago now. It was a little after the early onset of the COVID pandemic, and this was helping scientists analyze the various proteins in the SARS-CoV-2 virus, and this was one of the flows. So this required using the advanced photon source to look at the protein structure, do some visualization, and then create a repository of results and put those on a portal that could be accessed by other researchers. So this was really a great way to make this kind of data available to the broader community for the greater good. I see another question. Are Globus flows included in the subscription? Yes, they are included. So when you get a subscription, you can run these flows, and you can run as many, you can deploy as many of them as you want. And by the way, I should mention the flows are also, just like every other service and resource in the Globus ecosystem, the flows are they're subject to the same security and access control as anything else. So you can control who can register new flows, who can run flows, who can monitor and manage flows, and so on. So it's a sort of a first-class citizen, if you will, in that environment. Let's see, okay. And speaking of developing flows, one of the tools that we're developing, have developed, and is in use in a limited form is this thing called Gladier, the Globus Architecture for Data Incentive Experimental Research. It's a mouthful, but it's a wonderful set of tools, because creating some of these flows, especially the more complex ones, can be quite a development task. So we've made it such that you can greatly automate the development cycle and the deployment of the flow, and then you can just focus on running that. And much of this work is done by the Globus Lamp. So this is a group sort of within the broader Globus, the Globus department at the University of Chicago, that is really focused on doing what I think of as the cool stuff. So they're exploring, sort of pushing the boundaries of what we can do around data management and ways to make data more easily accessible, and so on. So that's one of the efforts out of that group. Another one that you can see here on the bottom right is FuncX. This is something that is also in limited production use, but something that we're working on to bring to the rest of the Globus community. And FuncX is really just functions as a service. But so if you're familiar with things like AWS Lambda or Google Cloud Functions or Azure Functions, it's the same idea, except that you're now able to register functions that execute on a federated compute infrastructure. So you could actually have them running on an HPC cluster, you could have them running on some supercomputing machine, what have you, and all of this is fully integrated with Globus Auth. So you have that full authentication authorization model tied to it. So this is something that, again, as I said, is work that's currently underway. It is already being used extensively in some projects, especially the Advanced Photon Source and a couple of other places. So there's sort of more to come on that. I'm seeing another question. When managing flows that should run repeatedly for long periods of time, do you need to get a renewable certificate for authentication? No. So the way that works is when they get registered, you initially have to grant consent, and that will get access tokens, and then with that come refresh tokens. So that will basically sort of stay. It'll be perennial, if you will, evergreen, and until the flow completes. So that I've talked a lot about all the feature function stuff. I will close with putting up our mission statement, which is to increase the efficiency and effectiveness of anyone that's doing data-driven work in science and scholarship, and doing so in a sustainable way. So a couple of people have asked questions related to Globus subscriptions. So many of you know that Globus is trying to become self-sustaining through subscriptions, so that we're not dependent solely on grant funding. Grant funding is still critical to our endeavor. It certainly funds all that cool work that I just talked about in the Globus labs. So we hope to continue to get support from the various funders out there. But in parallel, we are trying to operate the service at increasingly greater scale. I think we're now at upwards of 200,000 registered users and many tens of thousands of active endpoints every month. So if you're considering subscribing, we certainly welcome you. If you continue to use the free service, that's also fine, but that's our goal. And with that, I will press pause and open it up to any other questions. Anything else? Feel free to put questions in the chat or in the Q&A. I'll keep both windows up here. Question, do you work with customers on trainings on some of these features? Yes, absolutely. So we do have we do host obviously webinars from time to time that are open to everyone, but if anyone wishes to dive into these things in more detail, we have many levels of tutorials and exercises and things that we can work with you on. So we're more than happy to have you schedule something for your campus, your lab group, what have you, and we would do it, you know, whatever format makes sense. Probably still virtual for now, but at some point we hope to be able to go back on campuses and do those things in person. Where can we see more examples of how to use Globus as a front-end interface for data sets? Yeah, so I will show you another great example, and I'm seeing another question about talking about the modern research data portal. So that's perfect, because those two are related very much so. So I will show you. Let me actually go here and go to another portal, which is the coolest name for me, which is ACDC. .alcf.anl.gov. So this is the ALCF Community Data Co-op portal. So as you can see from the name, it's the Argonne Leadership Computing Facility owns and manages this portal, and this is actually built using the modern research data portal design paradigm. I'll talk about that in a second. But to the first question about search, this is a repository. So this is a portal that serves sort of as a window into multiple, in some cases, very substantial data collections. A particularly good one that's been around quite a while is this materials data facility. So this is a public one that you can actually go and poke around in. And you'll see resemblances to the previous one that I showed. So this one has almost 1 million data sets in it. And this is specific to materials science. So this is something run by Ben Blazik and his team. They've done a wonderful job of aggregating data sets from multiple different sources. So anyone who's built in the material science space can contribute their findings, their data, their experiments, what have you, to this portal. And this is a well curated data set that you can see is extensively indexed, where I can go and sort of look at specific things, narrow down my results, get, and then click Globus, and same idea. I get dropped into Globus, select my endpoint, do my thing. And so this portal is actually, as I said, built using this modern research data portal design pattern. And the modern research data portal is really, it involves a couple of different pieces. So the one is, the most important one arguably is having the underlying infrastructure in place, which is creating a science DMZ, putting your endpoint, your Globus endpoint in the science DMZ so that you can actually get the best possible data transfer performance. And then the second piece is running this portal, which you can actually run behind the firewall. In fact, that's the recommended architecture, because you have the sort of the additional business logic. So you can put that behind the firewall, but the portal itself doesn't have much data movement to and from it. It's just basically, simple web queries and things like that. When you actually have to move the data, so when I click on this Globus button or something equivalent, then it'll go on and you can fire off the asynchronous transfer, which will then use the endpoint in the science DMZ. So it's these various components working together to create both a robust, secure front end, but also a very high speed data transfer channel on the side. So this is a design pattern that was developed by the folks at ESNet and ourselves jointly some time ago. It's evolved some since then. But the fundamentals still are the same. We are actually in the process, and we actually do have another version of this portal. So we created a sample one originally using Flask. We now have one that uses Django. In fact, this portal here is based on Django, and we are in the process of packaging that in a way that allows you to stand up one of these portals literally with just a couple of commands, and actually have sort of instant gratification on search, assuming you've got some data to ingest into the search index. So that's thank you for those questions. That's really another area that's particularly exciting to me, because so many projects have data that they want to make more widely available with appropriate access controls, and that can be quite a challenge at scale. See if there are any other questions here. Anything else that I can answer? And by the way, to the point of trainings, we also have office hours every month. So it's sort of an open session that people can show up at, and we can dive into problems. We actually have one this afternoon for those who are interested at 3 p.m. Eastern, the Central. The links are on our website. And we are planning to have a webinar on specifically focused on cloud storage migration, where we can really dive into the specifics of the various connectors and the security model and things like that, which I know is of interest to many folks. Question: we're having issues with data transfer speed of large data set. Who's best to facilitate the use of science DMZ? Will that help speeding up the transfer? yeah, it's always a tough one when people say, you know, there's a problem with performance because there's so many variables. But certainly a good starting point is making sure you have a science DMZ, or you have a well-provisioned data transfer node, you have a clean path, you know, so you should be running things like perf sonar on your science DMZ, making sure that the path between your endpoint and various destinations doesn't have you know, issues with IP drop-offs and things like that. So TCP issues. So yeah, certainly that's a starting point. I will put in a plug for ESNet and the Epoch. They're invaluable resource for the community for helping people set up the right environment or troubleshoot their network environments to get optimal performance. They've done wonders, certainly within the national labs, but also for many campuses, both here and abroad. So do feel free to connect with them as well. If it's a specific issue with the Globus endpoint, certainly, you know, support@globus.org is another starting point for you, and we can always bring ESNet or others in if it turns out to be something related to networking. Another question: what about performance between cloud endpoints, e.g., Google to AWS or Google Drive to GCP cloud storage? Yeah, that's a great question. So that is an interesting question, because especially when you're dealing with cloud object stores, there can be substantial metadata overhead. And one of the things that we do encourage people to do is to, in general, not just for cloud stores, but just in general, you know, moving, you know, millions of tiny files is a sure way to kill performance on any type of link. It doesn't matter if you've got, you know, 100 gig pipe straight into AWS or Azure. So, you know, thinking about how you structure your data is really important. But, you know, assuming reasonable data structure, just in anecdotal testing that I've done, and I know others have done more formal testing, but you know, I've seen multi-gigabit sustained speeds in moving. In one case, I think I was looking at moving between Box and Google Drive, you know, both ways. Again, it depends on, you know, having the right type of data transfer nodes. Ideally, if you have a cluster of data transfer nodes, so you can sort of fan out some of the transfer tasks, and making sure you have decent bandwidth to your cloud instances. All those things sort of come together. You can actually get good performance. I will say that, you know, we do sometimes get requests from folks that have, you know, they stood up a tiny test instance somewhere, a VM somewhere in the cloud, and they're trying to push, you know, a terabyte of data through that, and they're not getting much joy. You know, there are sort of limits to all these things, so that you should be aware of. So, but we're more than happy to advise on those kinds of things as far as what's an appropriate environment setup, etc. What is the contact information for Epoch? That's a great question. I'm sure I have their website somewhere. I will tell you right now. I'll put it up here just a second. I think if we just go to es.net, here, I'll post it in the chat here. I think if you try that link here, so that'll take you to the Epoch, and then yeah, and this is actually their website. So epoch.global. There we go. That's probably the better link. Yeah. Still have a few minutes here. Be more than happy to answer any other questions. Okay, it doesn't look like we have any other questions. Susan, did you want to close it out with anything?
The recording will be posted on our website and the slides will be made available shortly. Thank you all for coming.
Thanks, everybody. Enjoy the rest of your day.